Okay, Bismillahirrahmanirrahim. So this will be the last question that we need to solve in this workbook under the class exercises. Okay, solve the differential equation given that this is ln x dy dx plus y over x equivalent to x ln x. Okay, so we are to get the y value, and definitely we cannot separate the variables. Okay, so let us compare work. Question number 3. Okay, so I'm rewriting back the question. Okay, so in order to solve this, we need first to multiply this question, okay, the differential equation here, with the integrating factor mu. Okay, so the formula of integrating factor is e power px. So hence we need to recognize the p. So you cannot straight away read from here, right? You have to rearranging it in this format, okay, so that then you can only recognize your p. What is the p? So to get into this format, what we should do first is we need to divide it by ln x. Okay, so I have divided the ln x. Divide by the ln x, we get this. Divide here with the ln x, we get x ln x, and divide here with the ln x, we get x. Okay, so hence from there we can be able to recognize our p. Okay, right. So into the formula of our integrating factor. Okay, make sure that you memorize the formula. So let's replace. Okay, here we have p being integral of ln x dx. So we need to solve this integration. Alright, so help me. How do we solve this integral of 1 on x ln x dx? What method is appropriate? And you cannot put in front the x, definitely cannot. Okay, x is a variable. Only if we have a constant, then you can put up front. So here we need to recall back on the lesson that we have had earlier on how do we solve this. Okay, help me. Maybe we can use a simple u substitution maybe. Okay. Here there's a mu. Let's call it let y lah, yeah. Y being, I have 1 on x, so let's take y as ln x. Okay, how do I know that is the appropriate substitution? Yes, it comes from your experience. That's why you have to do lots of exercises. So we need to differentiate there, and hence what is dy? Or dy here is 1 over x dx. So that you can see dy here is dx over x, and this is 1 over y. So this integral now, we can substitute. It becomes 1 over ln x is y, and dx on x is dy. Okay, there we simplified it. So hence we know that from a basic formula, integral of a integral of 1 over y is ln y. Okay, don't put down the c just yet. So replace it. So this is similar to say ln of, what is our y? It's a ln x. That's the format. Okay. So that is the format. And as we replace this value, okay, so let's replace this value. Help me. E power. So we have solved this integral. We get ln of ln x. Okay, simplify this. Okay, using the law of the log, I'm writing it down there. E power ln y is y. A format e power ln y. Okay, so the integrating factor, as we simplify this, we get ln x. Right? Okay. So up to that level, you have to be able to show, okay, your work. Okay, divide all, recognize the p, and Okay, trying to get to this integrating factor, you need to do to solve this integral, make sure that you show, okay, we are using a simple U substitution in terms of the y, and we get the answer over there, and we simplify into the formula just now and show that your integrating factor is A1. You do know that if you do not show your method, okay, M0 automatic A0. So next we go to step number 2. You are to multiply all this differential equation with your mu, okay, the ln x. Okay, so let me multiply my ln x, multiply with this dy dx, plus again ln x, multiply by this notation, okay, and ln x multiplied by this notation. Let's put the x up front. Let's simplify this first. So after we have simplified that, okay, and then you can see this notation, okay, you can refer back to the product rule, okay, such that if our f is ln x and our y is y, so f times y, the derivative of f times y is fy prime plus f prime y. So now we are to move from here to here, okay, so f dy dx plus f prime, derivative of the ln x is 1 on x and y. Do you see that? Okay, so hence if you are able to see that this is actually a derivative of f, our f is ln x multiplied by our y is y. Okay, so then we can combine it, right? Okay, so there, to be able to combine it, okay, there's a A1 there, okay, for this statement, and in order to do that you have to multiply all with our integrating factor just now. Okay, next step number 3, let's integrate all. Okay, let me bring up a little bit so that you can clearly see on the steps. Alright, so after this, in order to get the value, we need to multiply with this partial fraction dx. So hence our equation now will become d of ln x. Let me put the y in front, okay. So y multiply ln x, and then on the right side we get x ln x of dx. You have to rearrange like that. Okay, then only we can integrate both sides. Okay. So for s on the left side is easy, because why? When you are, for example, to differentiate, to integrate ds, the answer is s. Integrating dv is a v. Okay. So our notation of a variable here is y ln x. So the solution for the integral on the left side is a simple y ln x. Okay. But on the right side, how do we solve this integration? How? Okay, we have done this before, right? X ln x dx. Can we use a simple U substitution? It does not work. Okay. So why don't you pause this video? For those who have not solved this, okay, you are supposed to use IBP. Okay, integration by parts. Before I show to you the solution, everybody be responsible for your work. Okay, pause the video and try this one first. So let us compare work on our integral. We are using integration by parts, lihat, meaning here we have algebra, and we have log. Okay, so between log and algebra, the log comes first, meaning the appropriate u to use IBP, the appropriate u is ln x, and the dv is x dx. Alright, that's one. And then, in order to use this formula of our integration by parts, we need to differentiate. Okay, and over here, we need to integrate. Okay, we integrate both sides. Here we get b, here we get x squared plus 2. Make sure you show it, make sure it is correct. Okay, correct. And then into the formula of our IBP, alright, replacing the u and the v respectively. And we simplify. Okay, as here I have simplified. Check my work. This is x squared on 2. We need to differentiate further. This is a simple differentiation. And hence, okay, that is the answer for this portion of our integration. Okay, make sure that you show all of it. Starting again, there you can see for this IBP to works, you have to choose the correct u and the dv. So hence, just now we have y ln x. Okay, so we are stuck with that and we have solved it. Make sure that you show all the working there. Okay, so that is, we are quoting back the answer. And don't leave your answer like this. Make sure you simplify further. Okay, divide everything with the ln x. So we have x squared on 2. Divide by the ln x. We have x squared over 4 over ln x and the c over ln x. You don't need to factorize. You can just leave your answer like that. Alright, so let us count back how many marks does this question carry. So we compare, okay, the marks. So we started with recognizing what is dp to get our integrating factor mu. Okay, so make sure you have this formula showing it. And then we are to, in order to integrate this 1 over x ln x, we are using a simple use substitution. Make sure you show it. Okay, we get this. And then as we simplify further, this e power ln y, so we get this y, which is the ln x, a1. Right. And then step number 2, we are supposed to multiply all, okay, this equation with the integrating factor, the one that we have got just now, ln x. See, you have to be very careful with this. Okay, if this is wrong, definitely this answer there is wrong. Okay, but you can dissolve the m. Show that you are multiplying all the terms of your equation with your ln x. Okay, show it, this line, show it. And then you know that, or notice that this is actually a product rule. We have proved it. Okay, combine it. Okay, we are to look at this portion. Right. And then to get to that y, we need to integrate both sides. Show it. And this is a long integration. Okay, such that we are using IBP. The IBP itself carries 4 marks to solve. Show it. Okay. And then finalize your answer. Leave your answer as y only. So I counted, we have 12 marks altogether for this question 3. Okay, it's a long working. Alright, people, don't stop there. Make sure you do more exercises. Okay, hopefully, inshallah, you will understand this topic. Okay, so that is our last example. Thank you. Bye.